go. So this will be the part 3 of the Algebra 2 review. So let's try looking into this question number 7 once again. So here, first one, if you have to convert them into the exponential form, then this will be m to the 4 over 3, while the other one will be m to the negative 1/2. But when you have multiplying two numbers, you have to add up the exponent. So this will be m to the 4/3, adding negative, so which is the same thing as minus 1/2. And of course, when you combine these two things, this will be combining, having the common denominator, which will be 6. So we have 8 over 6 minus 3 over 6, which will be equal to 5 over 6. That means this simplifies into m to the 5 over 6 power. Then this means this is equal to choice number 4. All right, let us look at the next question. Here we have, when we want to make the denominator rationalized, all we have to do is multiply top and bottom by its conjugate. Radical 3 plus 5, same thing, top and bottom. Radical 3 plus 5. Then by the difference of the square, the denominator will become simply 3 minus 5 squared. Here we got 3 because of the radical 3 squared becomes 3 itself. In the top, we end up getting radical 3 times radical 3 becomes simply 3 plus 10 radical 3 if you do the FOIL, and the last one becomes plus 25. And if you have to simplify this one after all, then this ends up being negative 22, and then 28 becomes the top plus 10 radical 3. Once you simplify this one, you'll end up getting, oops, not this one, choice number 1, because divide everything by 2, then we'll end up getting this. All right. How about this one? Solve this one algebraically. Whenever we want to solve the equations with the radicals, what we want to do is we want to isolate radicals on one side and the other. So we will subtract 1 from both sides. And here we end up getting square root of 3x plus 1 should be equal to x minus 1. Now, when you square both sides after that, then on the left side we'll end up getting 3x plus 1. On the right side we'll end up getting x squared minus 2x plus 1. Now, bring everything onto the other side, we will get 0 equals x squared. When you subtract 3 x's from each side, we'll end up getting negative 5x. And subtracting 1, then 0, that's it. So obviously we can factor this one with x, and x minus 5 will be equal to 0. Then when you work this one out, x will be equal to 0 or 5. Now, but what we want to do is this, we want to check these values in the original expression. So, what if x was equal to 0? Then we'll end up getting 3 times 0 plus 1 within the radical plus 1 equals to 0. Then here we'll end up getting radical 1 plus 1. In fact, that's not equal to 0. So therefore, 0 has to be rejected. If you have to plug in 5, square root of 3 times 5 plus 1, and then plus 1, is that in fact equal to 5? Here we end up getting square root of 16 plus 1, and this becomes 4 plus 1. In fact, yes, it is equal to 5, so 5 is okay, which tells us 0 has to be rejected. All right, let us move on to the next question. Here we have rationalizing the denominator. Just like before, what we have to do is this. 5 over 3 minus radical 2 But we have to multiply top and bottom by 3 plus radical 2 on each side. Then numerator becomes 5 times 3 plus radical 2. And denominator simply becomes 9, which is 3 squared, minus 2. Then this becomes 15 plus 5 radical 2 over 7. That becomes our final answer. Alright, let us try to look into this one. Simplest radical form. So here, you can actually, because both of them are in the radicals, we can combine them, put everything into the radicals, then we'll end up getting 6x times y to the 5th power on the bottom. Top, we get 108. X to the 5th and y to the 8th. Then let us simplify the fractions first. Here, 108 divided by 6. I believe it becomes 6 goes in here one time, and 18. And then x to the 5th divided by x becomes x to the 4th. Here, and then y to the 3rd power. In fact, denominator simply is equal to 1. Then when you simplify, this becomes square root of 18, which we know how to simplify later. And this is radical 4. Radical x to the 4th power, that means simply x squared. And this one becomes square root of 3. Now, then I can break that into y to the square times square root of y. Then what happened? Yes, this becomes 3 square root of 2 when you simplify. X squared, this becomes simply y, and square root of y by itself. Then when you combine everything together, we get 3x squared y, the square root of 2y becomes our final answer. Alright? Next. Now, domain. When we say domain, within the square root, this portion, in fact, has to be greater than or equal to 0 at all times. That means x minus 2 has to be greater than or equal to 0 to have the function to be real. By adding 2, we get x has to be greater than or equal to 2, which will be simply choice 2. Now, in this case, we have the radical. But the thing is, the radical cannot be equal to 0 in this case, because we have some fraction over radical. This portion simply has to be greater than 0, unlike the earlier one. But because in this case, this expression radical wasn't on the denominator, but this one is. So therefore, this one cannot be equal to 0. In the fraction, when the denominator is equal to 0, the fraction is not defined. So therefore, what we have to say is x minus 1 has to be greater than 0, period. And this tells us by adding 1 to each side, x has to be greater than 1, which is choice 1. Here, let's try to look into this one. Now, domain, for this given domain, what's happening? Smallest value. Now, in order for us to find the smallest value, especially on the quadratic function, we always have to look for the turning point. Turning point, or so-called vertex. How do you find the turning point? X will be equal to, x value for that will be negative b over 2a. See, that's the turning point. So then, here, in this particular case, what is the value of b? B is in fact 0 because you don't have the x term. Over 2 times a is equal to 1, which simply is equal to 0. Now, then in this case, what we have to do is, smallest value is not only checking upon the endpoints, but also 0 also. Then here, what do we end up getting? X and y. So we have to check upon negative 3 because those are the endpoints. But we also have to check upon 0 because that's a turning point within them. So when you plug in negative 3, we end up getting 8. When you plug in 0, we get negative 1. And when you plug in 3, we also still end up getting 8. So therefore, our answer, smallest value in the range will be -1. Now here, well, in this case, this is a little bit different because they give you domain set as in particular value, -2, -1, and 0. Now, and we actually have to plug them in. X, Y, -2, -1, and 0. Once you plug in -2, we end up getting, this becomes 8 minus 6. So therefore we end up getting 2. And when you plug in -1, we get 2 minus 3 becomes -1. And when you plug in 0, we will end up getting 0. So 2, -1, and 0. Which will be choice number 2. Alright, so once again here, we're looking at number 5 is looking at the domain, essentially. And you will realize that denominator cannot be equal to 0. So x minus 3 cannot be equal to 0. That means x cannot be equal to 3. So therefore, our answer will be choice 3. What is the inverse relation? Inverse relation is simply switching x and y here, mechanically speaking. So this inverse of that will be x equals 2y plus 3. But obviously we don't see that, so we need to solve for y. Then by subtracting 3, so we get 2y will be equal to x minus 3. But dividing it by 2, so then y equals x minus 3 over 2. So choice 2 becomes our answer. Inverse of this function. Inverse of this function is simply switching values of x and y. Instead of having 2, 6, you will have 6, 2. Only possibility will be choice 3, for that matter. All right. Now, inverse function, graphically speaking, this one has to be, I only gave you 2 choices because I just want to show you, I'll show you that it has to be reflected through this value, y equals x. Imagine if this f of x has been reflected about y equals x, then it should have been somewhere around here. And that is choice 3. All right, how about this one? Then in this case, all we have to do is plug in n plus 1 in place of x's. Then we end up getting f of n plus 1 will be n plus 1 in place of x minus 2. And then you got to put n plus 1 in place of x here, n plus 1 plus 1. Then once you simplify this one, we'll end up getting n minus 1 on top and n plus 2 on the bottom. So therefore, this will be our answer, choice number 3. Now, then in this case, since 2, when x value was equal to 2, y value was equal to 12, let us actually plug them in. Then 12 is equal to k times x value was equal to 2 over here, 2 squared. Then here we have 12 is equal to 4k. Then dividing it by 4 on each side, we'll end up getting k is equal to 3. So 3 will be our answer. All right. The minimum point on the graph of the equation is this. The minimum point on the graph of, you see in this case, the plus 5 at the end, away from the f of x, this means moving it up by 5. You see, you're not changing anything by x value, but only the y value would be moving up by 5. So if -1 come up, -3 what to be the minimum value, then our new minimum value would have been -3, but we have to move the y value by 5. That means this will be -1 comma 2, which is choice number 1. Once again, unlike the other one, this one has been x has been added by 2. So this means opposite of that sign. So we have to move to the left by 2. Moving this one left by 2 units will be choice 3, it seems. Or 2, whatever this one is. All right. Here, let's try to look at this question together. is the relation of function. In order for us to see if this is a function or not, all we have to do is vertical line test. Here's my vertical line. And as I'm moving these vertical lines around, do I only intersect with one point on the graph? Yes, it is. That means it is a function. So therefore, A is yes. How about B? Domain and range. Domain is the x value. Now, assuming that x values are here, 1 unit square. So I'm going to assume that this is 1, 2, 3, 4, 5, 6. Domain goes from -6 to 1, 2, 3, 4, 5, 6. +6. +6. Outer bracket. Range goes as low as right here, so which is -4, and as high as 4. Alright, is it 1-to-1? In order for us to see something is 1-to-1, what we need to do is we need to look at the horizontal line test. But when you look into this one, as I'm moving around, you see I have 2 points of intersection. Therefore, this one is not a 1-to-1 function. Now, number 2. Same way as before. If I bring this one, if I try to use the vertical line test, it will not pass because I have 2 intersections. Therefore, A here is no. If A is no, that means C will automatically be no too, because it's not 1-to-1. I have one value of x has 2 values of y. Now, domain and range. In this case, even though it's not a function, in a relation, we get to realize that domain will be less than 0, it seems. So we have -infinity. Whenever you have infinity, you have to use a soft bracket to 0. How about range? Range seems to be, I can go down as low as I want or as high as I want. So I forgot the negative sign. -infinity to +infinity over here. All right, let's move on to the next. Same kind of question here. Is it a function? Doing the vertical line test. And then, is it 1-to-1? So first, when you look through that, it seems to be passing the horizontal and also vertical line test. So therefore, this means, because of the vertical line test, yes, it is a function. Since it passes through both, C, it is 1-to-1. Domain seems to be values of x from 0 and below, so -infinity to 0. Range, on the other hand, it goes down as low as 0 and as high as infinity. It seems ever increasing function, so that's basically what's going to be happening. Here, second, number 4. Is it a function? Yes, it passes through the vertical line test. But you'll realize that it doesn't pass through the horizontal line test, such as these. Which gives us, it is a function, yes, but see, no, it's not 1-to-1. Domain, since it covers all the x values, so domain seems to be -infinity to +infinity. And range is also -infinity to +infinity. All right. Next. When you multiply I, write the rules for the following function. This simply means we got to combine those two things. We got to multiply these two things. So f and h, we just have to multiply them. Then this is equal to 2x minus 5 and x squared minus 16. Since both of them are simple polynomials, there is no restriction on the domain. How about second one? since this is a fraction, g square root of x plus 16 over h of x becomes x squared minus 16. Now, because of the numerator, we get to realize that x plus 16 has to be greater than or equal to 0. That means x has to be greater than or equal to negative 16. On the other hand, by looking at the bottom portion, this cannot equal to 0. That means by factoring, we get to realize x plus 4 and x minus 4 will be factored. And these cannot be equal to 0. Now, this means x cannot be equal to 4 nor negative 4. So here domain is x such that x has to be greater than or equal to negative 16, but x cannot be equal to 4 or negative 4. Alright, so we're going to stop now and continue later. Have a nice day.